Welcome, everyone. Thanks for tuning into the session on AI agents and agentic workflows. Today, we are going to deep dive into building autonomous agents using Claude Code, Anthropic's command line tool that lets you delegate real coding work to Claude. This isn't going to be theoretical talk. We'll cover what agents really are, how they differ from chatbots, and then we'll build one live. By the end of the session, you'll understand how to design, deploy, and trust agentic workflows in your own projects. If you're new to this channel, hit subscribe. We drop hands-on cloud and AI content every week. Let's get started. Here's our roadmap for today. 6 clear sections. First, we'll align on what AI agent actually is, because the term gets thrown around loosely. Then we'll talk about why Claude Code specifically before pulling apart the anatomy of an agent, the loop, tools, memory, and planning. Section 4 is the fun part. A live code of bug fixing agents and in about 15 minutes. Then we'll cover production patterns, the boring but essential stuff like guardrails, cost tracking, and observability. Finally, I'll teach you two resources to build your first real agent this week. Drop a comment with which section you are excited most about. Let's get the definition right. An AI agent isn't just a smart chatbot. Three things make it an agent. It reasons. It picks the next action itself instead of following a hard-coded script. Then it acts. It calls real tools like the shell, file system, APIs, and search. It loops. It observes the audit of an action and decides what to do next, repeating until the task is done. Basically, a chatbot answers your question, an agent does the work for you. That distinction, autonomy in the loop, it's the entire game. If your system can't take the action, see the result, and decide what to do next, it's not really an agent. It's just a wrapper around an LLM. Why Claude Code? There are a lot of agents framework out there. LangChain, AutoGen, Crew AI. So why Claude Code? Four reasons. One, it lives in your terminal. No new IDE to learn, no plugin to install in 17 places. Two, it reads and edits your files. It understands your whole repo, not just snippets you paste. Three, can run for a long time on multi-step tasks. We are talking hundreds of tool calls in one session. 4. It's permission aware by default. Task before doing destructive things like deleting files or running migrations. On the right, you can see what a real session is like. You tell it what you want and it plans, reads, edits, tests, and iterates. Let's see the anatomy of an agent. Every agent, Claude Code included, runs the same loop. Step 1, plan. The model reasons about the goal and picks the next action. Step 2, it calls a tool, reading a file, running commands, searching the web. And then 3, observe. The result of the tool call comes back into the conversation. And step 4, decide, is the task done or are we going to loop it again? The dashed line back to plan is where the magic happens. Each turn, the model sees its full history, every action, every result. That's how it self-corrects. If it ran a test and it failed, it sees the failure and tries something different next time. When you build agents, you are really designing this loop. What agents the tool has, what context it gets when it stops. All right, here's where we put theory aside and build something real. I've got a small Node.js project on GitHub with intentionally 3 broken tests. The plan is to clone the repo, run Claude from the terminal, give one instruction, make all the tests pass, and watch what happens. I'm not going to write any code myself. I'm going to give it the goal and let it work. You'll see it form a plan, read the failing test output, identify the bugs, edit the source files, read on the test, and iterate until everything is green. If you want to follow along, I'll pin the repo in the comments. Let's switch to the terminal. So let's see what just happened. Three things I want you to take away from the demo. First, it planned before it acted. Notice how before touching any code, it read the test file and the source file to understand the situation. Plans first, executes second. That's why the output stayed coherent across many steps. Second, it paused for permission. The first time it wanted to edit a file, it asked. You can configure how aggressive that gating is, but by default, you stay in control. And third, it self corrects itself. In case if the first fix doesn't pass, the agent will not give up. It rereads the failure, forms a new hypothesis, tries again, and gets it right. That's the agent in real life. This is what makes agent qualitatively different from autocomplete. A demo running on your laptop is one thing, putting an agent into a real workflow is another. Four patterns that matter. 1. Scoped permissions. Whitelist the directories and commands that agent can touch. It should never have access to etc or be able to, that is, remove any files it likes. 2. Budgets. Set a maximum number of turns and a wall clock time limit. Agents can loop forever if you let them, and that translates into surprise bills. 3. Observability. Log every tool call. When something goes wrong at 2 a.m., you need a trail. 4. MCP. Model Context Protocol lets you wire up your own tools, your database, your internal API, your documents. That's where agents stop being a toy and become genuinely useful for your specific problem. Common pitfalls. Mistakes I have done so you don't have to. Pitfall 1. Too many tools. The more tools an agent has, the worse its decisions get. The model has to choose between them, and choice paralysis is real. Start with 3 to 5 tools. Add more only when you have measured a clear gap. Pitfall 2. Vague goals. Improve the code is meaningless. The agent should do something, but you won't be happy with it. Give it a measurable success criteria. All tests pass, P95 latency under 200 ms, whatever. Pitfall 3. No human checkpoint. Auto approving every action is fine for a sandbox. Never do it in production. Always have human in the loop for irreversible changes. Pitfall 4. Ignoring the cost. Long agentic runs burn tokens fast. Track tokens per task. Set hard caps. I've seen people get a 4-figure bill from one misconfigured loop. 3 concrete steps to go from watching this video to actually building. Step 1. Install Claude Code. One npm command, run it inside any repo to start. Pick one painful task, something you do every week and hate. Test triage, log analysis, document updates. Don't pick something glamorous. Pick something annoying. Step 3. Ship a tiny version. Get it working end to end before you polish anything. Then add one MCP tool, then iterate. The number one mistake I see people trying is to build the perfect agent on day one. Dude, build a bad agent first. Make it less bad next week. That's a wrap. Quick recap. We covered what an agent really is, why Claude Code is a great place to start, the agent loop, a live build, production patterns, common pitfalls, and your 3-step homework. 3 ask. 1. If this was useful, hit subscribe. We do weekly cloud and AI content like this. 2. The repo from the demo is linked in the description. Clone it, try it yourself. 3. Drop your questions in the comments. I read every single one and I'll pin the best ones. What should I build next? An agent for log analysis? A multi-agent setup with MCP? Tell me below. Thanks for watching. Now let's build something.